This episode of the Talon Talks podcast was recorded earlier this year. For the latest on how the university is responding to the coronavirus pandemic, please visit erau.edu/coronavirus. Here's the show. Welcome to the Talon Talks podcast from Embry-Riddle Aeronautical University. I'm Alan Caesar. My guest today is Anthony Brickhouse. He got his bachelor's in aerospace engineering in 2001 and a master's in aeronautical science in 2002. He has been part of our faculty since he graduated and is now an associate professor of aerospace and occupational safety and director of the Aerospace Forensic Lab. He's also a member of several professional organizations focused on aviation safety and investigation. Anthony, thanks so much for joining me today.
Thank you for the invite.
All right. So how did you go directly from completing your master's to being on our faculty?
Well, I was actually working in our aviation safety office at the university as an associate director, and my boss, who was the director, took a job at FedEx. And during my time working with him, I would sub for him whenever he traveled or anything like that. So when he left for FedEx, they needed someone immediately to teach that course, Summer A 2002. And they asked me to teach it. I had been helping out for several years and was comfortable with the course material. And about midway through that summer semester, the department chair approached me and asked me if I had any interest in teaching full time. And that was something that I had always wanted to do, but I always thought that I would go out in industry and work for 20 years and then come back to Embry-Riddle and teach. But things did not play out in that order.
That's pretty funny. So you initially went into aerospace engineering, but then went for aeronautical science for your master's. Tell me why you didn't stick with engineering.
Correct. Straight out of high school, I went into the aerospace engineering program here at Embry-Riddle. And about midway into it, I decided that I did not want to be a hardcore aerospace engineer. So at that time, I took a course in space operations, basically, and a course in aviation safety to pick up a minor to go along with engineering. And I gravitated toward the aviation safety course a little more than the space course. And I finished my bachelor's in aerospace engineering, did a minor in aviation safety, and things pretty much played out from there.
Right on. So you do a lot of TV interviews. You've gotten a bit of a clout to your name. You're a bit of a subject matter expert on crashes. How do you prepare for doing an interview for mainstream, television?
Fortunately, most of the interviews that I do are the same topics that I teach on a weekly basis here at the university. So I may look at the accident that has happened a little bit, but obviously with a lot of accidents, the first few days and weeks, the information isn't accurate. So I really don't do a lot of preparing. I just basically talk about the same topics that I talk about in class.
All right. So the Aerospace Forensic Lab, when I first read that name, I thought this was about finding murderers on the International Space Station. It turns out it's the crash lab here at Daytona Beach, and that you helped get it set up. So tell me a bit about that, how that happened.
Sure. I think people hear the word forensics, and thanks to the wonderful television shows that we have now, they think we're investigating murders or things like that. But we use the word forensic because we're basically looking backwards, trying to figure out why an accident happened. So we I've been trying to get a crash lab for years. One of my predecessors and mentors, Professor Don Hunt, tried for years to get it, and we couldn't get it established. So finally, we actually encouraged the students to start a petition. And they got about 500 signatures, and that petition went to everybody from the president on down. And within months, we had the crash lab, which is an excellent teaching tool to supplement what we do in the classroom.
So what parts of the crash lab experience is it really important to see in person versus, reading in a textbook?
Literally, it's every component from actually arriving at the crash lab. And these students are mostly seeing these crashes for the first time. So it's pretty shocking when they first get there. And then we do site documentation, trying to document the wreckage and how the wreckage broke up. And then the students eventually get in and look at the pieces of the puzzle, as I call it, to slowly try to piece things back together and actually figure out what happened. And these are all actual accidents. All of them involve fatalities, unfortunately. And we try to learn from those accidents and educate the next generation of air safety investigators.
So when you set up these, obviously these planes didn't all crash in that exact same spot.
No.
How do you acquire these wrecked planes?
Typically, after an investigation, the NTSB wraps up their job. The wreck goes to an insurance company. And once the litigation has wrapped up, which can be years, insurance companies decide what to do with the wrecks. And we typically keep an eye on what's happening with different aircraft crashes. And we reach out to the insurance company, and they basically donate the wrecks to the university. And typically, we just pay for the shipping to get them here. And then we get them in the crash lab, we study the real accident, and we actually try to set the wrecks up just like they were at the real crash site.
Oh, so you do recreate them almost
Yes,
exactly as exactly as you can.
As closely as we can.
Yeah. Is it straightforward when they? So first of all, are these crashes are this the causes known, or are there any that are still mysteries?
We have one wreck at the crash lab where the NTSB could not determine the cause. For the rest of the wrecks, yes, the causes are available.
So is it relatively straightforward, or are there a lot of sort of red herrings when you're looking at a crash?
There are always going to be red herrings, and even if they're not, we create them just to challenge the students.
A little obfuscation going on there.
Absolutely.
All right. What are some of the harder causes to pinpoint when it comes to a crash?
Wow, that's a good question. Sometimes with the human element, trying to look into human factors, trying to figure out how humans interacted with each other. Let's say in an accident where there was nothing recording on that aircraft. They weren't communicating with air traffic control. There was no cockpit voice recorder. Nothing was being recorded on the plane. That can be pretty difficult. Sometimes structural failures can be pretty difficult to figure out because you really have to backtrack and try to figure out, what caused the situation to happen. So every accident presents its own challenges. And typically in accident investigation, we train that if the cause looks too readily apparent, it's probably not the correct cause.
That's interesting. So if you come in there and it looks really obvious, it's most likely something else.
Most likely it's not what you think.
All right. So I read that both Delta Airlines and American Airlines are donating biosuits for students to use at the crash lab. What are those suits used for? What are they for, and how will they be used?
Yes, a huge thank you to American Airlines and Delta Airlines for donating some of their expired biosuits. Basically, what we do at the crash lab is we simulate bloodborne pathogen issues that a real investigator would have to deal with. And when we go to the crash lab, several students from each group, they have to put on their bio gear and act like the crash site is contaminated. And it involves actually putting on the suit properly, operating at the crash site and taking pictures or whatever you need to do. And then once you finish, after you possibly have gotten biomatter on you, actually properly taking off the suit. So once again, a big thank you to the airlines for helping out, because it's really important that students get that experience before they actually do it for the first time in the real operational world.
So that's something that I didn't think a whole lot about, is the fact that, with a crash like this, that you as an investigator could get sick. Does that affect your daily life?
It causes you to think about germs and pathogens more often. I wouldn't say that I'm a bona fide germaphobe, but I do have my wipes nearby.
I see. So I saw that you have some accident investigation experience at the NTSB going back to 1998. How did you get that job and get into this field?
It's a really interesting story. I guess it would have been fall 1997. I attended the Career Expo that the university puts on every year. And back then, I think we only had one. And the NTSB actually had a booth at this Career Expo. And being an aviation safety minor, I wanted to work for the NTSB. And I approached the table, talked to a few people, gave them my resume, and we probably exchanged cards or something like that, and I went on my way. That was probably October. December of that same year, I'm at home with my folks in North Carolina, and the phone rings, and my mom is like, Tony, NTSB's on the phone. And I'm like, come on, Mom, the NTSB's not calling me. Like, why would they call me? And she hands me the phone, and it was the NTSB, and they offered me a position for the summer of 1998. And that was an outstanding experience, and I can honestly say, without that summer, I would not be sitting here as faculty at Embry-Riddle right now.
So was that when you were working in the vehicle performance division?
Yes, I was assigned to the Vehicle Performance Division in the Office of Research and Engineering. And in that role, we basically supported investigators in the field doing performance calculations. But I wanted to be a field investigator, so I made it my business to meet as many field investigators as I could. So whenever an accident happened in the immediate area near Washington, D.C., I would get a chance to launch to the crash site and do on-scene investigations.
So what does vehicle performance division mean? It seems like a really vague term.
It's a huge term. It doesn't necessarily mean airplanes. I'm coming from Embry-Riddle Aeronautical University,
right.
from an aerospace engineering program and an aviation safety minor. And the first accident that I worked on was actually a school bus crash in California. Unfortunately, the bus got into an accident and flipped over, and no restraints on the bus. Unfortunately, we still have buses today that don't have restraints. And obviously, when the bus went over, kids unfortunately flew around and several died. And our job was to get in and do performance calculations to explain the forces that were happening during the impact.
Yeah, so, well, that leads to my next question. Accident investigation is an absolutely necessary job to keep our skies and our roadways safe, but it's also really grim. And you co-authored a paper called Mental Health and the Air Safety Investigator, where you surveyed aircraft accident investigators to see if the impact of the job on their mental health and their personal lives. Tell me how you came upon this idea to do this study.
Well, that actually dates back to 2005 when I attended my first seminar of the International Society of Air Safety Investigators, or ASASI, in Fort Worth, Texas. And there was an Irish investigator by the name of Mary Cotter who was there, and she did a presentation on that very topic. And it really piqued my interest because I had never thought about that before. And then fast forward a few years, I guess it would have been 2009, a student at the time, Brian Dyer, came to me wanting a topic for an essay. For a scholarship, and we decided he was going to write about that topic, and it basically played out from there, and it culminated with the presentation at that same organization seminar in Sapporo, Japan in 2010.
So the symptoms that people in this field experience line up with post-traumatic stress disorder and some other types of emotional illnesses as well. How can somebody mentally prepare for going into this to sort of mitigate the effects of that?
Yeah, PTSD is obviously a huge problem, and we have experience with that from our brave service members serving in different theaters of operation. But as it pertains to air safety investigators, there's really no formal training. So our research was looking into the feasibility of having some type of annual training module for air safety investigators. Not necessarily so that you can prepare for what you're going to see, but so that you can be conditioned and have an expectation of what you might see. So that would be on the front end. During the course of the investigation, there would be considerations to support investigators. And then obviously after the investigation is over, there would be some type of training incorporated to help people deal with the stressful things that they possibly had to deal with. And that's actually the ultimate goal of this research, is to script a mental conditioning model that we can roll out and give to air safety investigators to use.
I read in the paper that you wrote that one participant said that they won't go to barbecues anymore for a while after dealing with an accident. That sounds like something that somebody would say from experience. Like that person didn't hear that from somebody else. That sounds like a really visceral kind of thing, and that sounds almost impossibly hard to deal with.
It's hard. It's really hard, and unfortunately, what you experience, it never goes away. It may be dormant, it may be latent, but let's say with the whole example that you just brought up, that could have been 30 years ago, and you get called to a new accident where there's been a massive fire, and the scent hits you, and it automatically brings back those memories from years ago. And it's just something that investigators have to deal with and focus on the end game, which is figuring out what happened so that we can prevent that same thing from happening again. But it's not easy. It's very challenging.
Yeah. So is it more about putting up a mental wall and trying to compartmentalize this, or is it more about understanding your triggers so that you can avoid them?
I think it's both of those. Personally, I try to separate myself, and I kind of have regular Anthony and investigator Anthony,
Mm-hmm.
and not even just with bloodborne pathogens, but just investigating accidents, especially fatal accidents. You have to step outside of yourself and just zero in on figuring out what happened at any cost, so that the same thing can be prevented from happening again. But it's hard to do.
Yeah. So that paper was published in 2011, and correct me if I'm wrong, I think it said at the time that less than half of the organizations that you looked into had some sort of training for before or after these incidents for people in these jobs. Do you know if that has changed since then?
Just by talking to different people through various travels, I don't think it really has grown much. And that's why we're really eager to get working on part 2 of this research, to see where we are now and to see how we can move forward.
Mm-hmm. How do you currently prepare students for that part of the job?
Well, we talk about it in class. We do show some pretty gruesome pictures, not to glorify, but to educate. We use the crash lab. We have discussions, but there's really no perfect way to prepare for it. We encourage students to do internships and co-ops so that they can actually go out in industry and go to the scene of a fatal accident to see if they can deal with it. Because a lot of people say they want to be air safety investigators, but when they actually get there and see what's involved, they may want to do something different.
Yeah. How do you encourage somebody to get into this field?
I'm not a huge person to encourage others, except by leading by example, I guess you could say. The important thing to note, though, is that aviation safety isn't only investigating, fatal, gory crashes. There's a proactive side of safety where you're trying to use management techniques and things like that to prevent the accident. And to be honest, I tell my students, if all you can do is investigate, then you're probably not going to be working often, because relatively speaking, we don't have that many accidents anymore. When they happen, they need to be investigated, but you have to be able to do other aspects of safety. And that's a good thing, because you're not dealing with the gore, regularly.
Right. You co-authored this textbook, Human Factors in Air Transport, Understanding Behavior and Performance in Aviation. I tend to think that humans have this flexibility in dealing with situations that automated systems historically have not had, that sort of flexibility. Though automated systems do get better all the time, humans also have a tendency to get distracted, make mistakes. Can you tell me about one of the major improvements you've seen in understanding and accounting for the human element in this industry?
Well, when we look at accidents, a high percentage of accidents are caused by humans and mistakes that we make. And automation was created for several different reasons. One of them to help pilots and operators not make some of the mistakes that have caused accidents in the past. And we could do a whole different show on automation, because it's such a vast topic. But typically, if the automation works properly and the humans interact with the automation properly, we're okay. But unfortunately, sometimes, as we've seen with several accidents, the human relies too much on automation. And we get into what you call expectation bias, where you are expecting the system to do something because that's what it's always done. But on that particular day, it does something different. And you get caught behind the power curve, or you get caught on your back foot. And we've seen several accidents play out because of that.
So how do you mitigate the risk of pilots and automated aircraft control systems working against one another?
Even though the automation is there, keeping pilots engaged and having them not simply just monitoring the system, but having them actively involved in flying. From my perspective as a safety guy, I think that's an important step to do.
So you've studied lightweight data recorders in general aviation, and most general aviation aircraft don't have these sorts of black boxes. Is that right?
That's correct.
Okay. So what would if we lived in a world where, if we snapped our fingers and all general aviation aircraft had these black boxes, what would that sort of do for aviation safety?
Well, the lightweight data recorders are like little brothers to the traditional cockpit voice recorder and flight data recorder. So traditionally with small aircraft, before we started putting SD cards in, and before we had ADSB and glass cockpits, if a small plane crashed, you weren't going to get anything. But now with ADSB and SD cards, we have a chance to get data. But those cards aren't fireproof. They aren't crash proof. So if you have a high velocity crash, they're not going to survive. The lightweight data recorder is hardened, just like a regular black box would be. And I have experience with the L3 aviation recorders, lightweight data recorder. And theirs basically records audio, video, it records GPS, and it also records flight data. So you're getting those 4 streams of data for a GA aircraft in a box that fits in the palm of your hands. So from an investigative point of view, now with the small aircraft, you're going to get detailed information, including video, of what that aircraft was doing. So now, instead of an investigator being on scene for maybe 3 days, kicking 10, as we call it, maybe you're only on scene for a day and a half now because you have more digital data to work with.
Okay. So that can help determine causes of these smaller aircraft accidents. Yes. Are we close? Do those exist right now? Are we close to having them available?
They've been out on the market for years, but in the U.S. right now, there's no mandate to install those on small aircraft and helicopters. The Canadians did put out a mandate a few years ago, so they're working toward that. There are several operators in Europe that already have them installed on their planes. So as with everything else with safety, the government looks at the financial impact. As a safety guy, I don't care about how much it costs. I want to save lives, but that's not the perfect world that we live in. But since the technology is out there, hopefully we'll see more and more lightweight data recorders and other types of recording devices that can help us piece together what happened.
Yeah. So you're a coordinator of student outreach and mentoring at ASASI. Tell me about what you do.
Correct. ASASI is an outstanding worldwide organization for people involved in air safety investigation, aviation safety, and accident prevention. And probably back in 2011, the president of ASASI, a gentleman by the name of Frank Delgandio, approached me and asked me to create and stand up a student mentoring program. So what we do with that program is ASASI has probably 1,500 members or so worldwide. When students join as student members, we have them fill out a survey. And if a student tells me that they want to work for a general aviation manufacturer as an air safety investigator, we have about 50 industry professionals sign up to be mentors. And what I do is I hook the two of them up. And now that student actually has someone in industry currently doing what they want to do. And it's just an excellent resource for them to communicate with. And ASASI has various conferences and meetings throughout the year, and those students actually get a chance to meet their mentor. And it's just a wonderful program to once again nurture the next generation of air safety investigators and aviation safety professionals.
Did you have a mentor like that when you were a student?
Not necessarily through ASASI, but through professors at the university and people in industry. Yes, I did.
Yeah, you want to name one of them?
I can name 2 or 3 huge ones. Dennis Jones, who is an alum of the university, was and is a mentor. Greg Feith, another alum of the university, was and is a mentor till this day. And those are just 2 people.
Yeah.
But my professors were the folks that I saw on a daily basis, and without them, I wouldn't be sitting here.
Yeah. Dennis Jones and Greg Feith, both gentlemen we featured in Lift magazine, actually.
Great.
Which thanks for leading me into our promo for the episode.
No problem.
So we'll continue on to the lightning round in just a moment. But first, I'd like to tell our listeners about Lift magazine, which is Embry-Riddle's flagship publication and #1 source of university news among our alumni. I'm actually one of the writers for Lift, so along with my colleagues Melanie Azam and Cindy Puckett, and our editor Sarah Withrow. We all have a journalism background, and it's our mission to tell stories about the Eagle community and the aerospace industry. We feature alumni who are excelling in their field, as well as those who followed non-traditional career paths after graduation. We also cover Embry-Riddle history, and every other issue we take a deep technical dive into an important topic in the aerospace industry. We've covered cybersecurity, the pilot shortage, the commercial aerospace industry, unmanned autonomous vehicles, and more. A Lyft subscription is completely free to all our alumni and friends of Embry-Riddle, so you can visit lyft.erau.edu to read the latest issue online and hit the Update Your Subscription link in the navigation menu to subscribe by paper mail or electronic mail. Now that we're done with all that, are you ready for the lightning round?
I think so.
All right.
Maybe.
I'm going to give you 5 questions, and you're going to give me 5 answers, and hopefully this will be easy and fun. So you can go. I gather that you're a bit of a sports enthusiast. If you can go to any championship event, whether it's a game or a race, past or present, what would it be?
Any championship involving the Tar Heels of the University of North Carolina at Chapel Hill, wherever the championship game is, and then get back to Franklin Street to celebrate.
Right on. Hopefully they win then.
Not this year.
No. So are you from that area?
I'm from Eastern North Carolina originally, yes.
Okay. All right. If you could read only one book for the rest of your life, what would it be?
Wow. Anything aviation safety related. I can't name one in particular.
All right. Hopefully it'll self-update with revisions, right?
Yes. Different versions.
Who's your favorite cartoon character?
Probably Jerry from Tom and Jerry.
Oh yeah.
Yeah.
That's good. That's good.
I like Jerry.
So picture for me your ideal grilled cheese sandwich. You're about to take a bite out of this. What's in it? What's it made of?
Actually, I need to go back. Bugs Bunny, then Jerry.
All right.
Okay, grilled cheese sandwich.
Hold on. Now I need to know more. Why Bugs Bunny over Jerry?
Bugs Bunny was just a cool character.
Yeah.
And he also did some aviation stuff in the different cartoons. So, and plus he was a rabbit that walked on 2 feet. That makes him cool.
All right. All right. Let's get back to the sandwich now. Yeah. So your ideal grilled cheese sandwich. What's it made of and what's in it?
Something other than the typical cheese that we get every day.
Okay.
Nice buttery layer on the bread, and you got to put bacon in. Bacon makes it better.
All right. What kind of, do you have a particular cheese in mind?
Just anything other than like cheddar or American. Maybe some Gouda.
Oh.
Something like that.
Gouda, nice and smoky and fun.
Exactly.
All right. Yeah. Okay. So last question. If you could live for a week as any person in history, who would you be?
I'm not a religious person, but I do like the biblical character of Paul.
Okay.
So Paul would be my answer.
Tell me a little bit why.
Well, he just lived an amazing life and did a lot of different things, and things didn't always work out for him. But in the end, everything fell into place. And not comparing myself to Paul, but I think it's important, like in life, when things don't add up perfectly, you just keep going and things always come together at the end.
All right. Well, thanks very much, Anthony, for joining us for the Talon Talks podcast.
Thank you.
All right. Talon Talks is a production of Wicked Radio and the Embry-Riddle Office of Alumni Engagement. We're coming at you from the Maury Husseini Student Union at Embry-Riddle Aeronautical University in sunny Daytona Beach, Florida. If you'd like to share your thoughts about our show or suggest a guest to us, we'd love to hear from you. Visit alumni.erau.edu/podcast and click the feedback link. Thanks for downloading us. We'll see you next time.